Okay, in this lesson we are going to be looking at creating scatter plots and finding lines of best fits and then using them to make predictions. So here is a set of data that we are looking at. We are looking at the number of mumps cases in the United States by year. And so what we want to do is we want to be able to plot that data on a coordinate grid as ordered pairs. And so what I would want to determine is there sort of a cause and effect? And I would guess I want to check out the number of cases by year. And so the part that is dependent, and so the number of cases depends on what year it is. I would put the dependent variable on the y-axis, so this is going to be my y, and the independent variable on my x-axis. So the year will be on my x-axis, and the number of cases will be on my y-axis. So I want to make sure I label those. Number of mumps cases. And then down here would be the year along the x-axis. Every graph should have a title too. So I'm going to do this. U.S. mumps cases by year. Okay? Now, when you do this, you do not need to start either your x or your y-axis at 0. Just so you know, when you're doing scatter plots, you do not need to do that. So, if I look at just what should go along my x-axis, the years in this case, I notice that the smallest year I need to plot is 1995 and the biggest year is 1999. So I should just be able to count by ones there. You do need to scale your axis evenly though. So you can't just take and go the way the data is and go, oh, this is 1995, 1996, and actually in this case I could, 1997, 1998, 1999, because they do all jump by 1 year in this case. But sometimes if one jumps 1 year and another one jumps 3 years, you can't just take and label your points that are on the bottom of your axes and go that way. You need to make sure they all jump evenly. So in this case they are all in increments of 1 year, so you can just keep going as you move across. Okay, then along your y-axis, you need to get from 387 all the way up to 906. You don't necessarily need to start at 0, but I'm going to start at 0 in this case just because it kind of makes sense. So if I have to get all the way up to 906, I'm going to go up to 1000, and I'm going to scale my axis by 200s here. Okay, so I will go like that. Again, your y-axis needs to be scaled evenly, and you need to put all of your points on there, okay? So now I am going to plot the point 1995 and 906. So 1995, I'll go along the x-axis. 906 will kind of be up right about here-ish. Okay. Then 1996 and 751 will be right about there. 1997 and 683 will be about right there. 1998 and 606 will be about right there. 1999 and 387 will be right about here. Okay? So that's what my scatter plot would look like. Then what you want to do, and that of course is always an estimation. When you do this by hand, it's never going to be perfect. Okay? Here's what it looked like when I did the computer screen. Then what you want to do is you want to draw a line of best fit in there. I have one drawn. Now, you need to know that the line of best fit at this point, at this stage in the game, since we're doing this by hand, is really an estimate. Okay? But the line of best fit is a line that you want to draw in that sort of averages out those dots. So you want to have some dots below the line, some dots above the line, and you want to have a line that kind of averages out those dots. Okay? I would not want to draw a line like this, okay? Because then I'd have 4 dots below it, 1 dot above it, some dots that are very far away from the line, some dots that are not very close to the line. You want to draw it so that you have that line kind of averaging out those dots. Excuse me, I'm going to have to sneeze. Maybe not. So that's the line that I drew in. Now, yours might not be exactly like mine, and that is okay, because we are going to be a little bit off here. Then what you need to do is you need to pick two dots that are on that line. It does not have to be one of the black dots, okay? Just so you know. But you need to find 2 points that are on that line. Here's the points I'm going to pick. I'm just going to pick this point right here. Okay, notice it was not one of my original dots. I know that. I am going to estimate that point at 1996 and 825. Okay, then I'm going to pick another line, and I am going to go, let's say, right here to this point. It's not quite one of my original dots, but I'm close. And that point would be the year 1997. And 650, let's say, okay? I am really estimating here. When you do this by hand, you're going to be a little bit off. But now you have 2 points, and once I have 2 points, I can come up with an equation. So the first thing I need to do with those 2 points, and again, pick any 2 points that are on the line. It does not have to be one of your original dots, okay? Once you do that, you're going to find the slope. So we'll call this x1, y1, this x2, y2, okay? So I will go 650 minus 825 over 1997 minus 1996. Oops. And so I will get negative 175 over 1, which of course is negative 175. Oops. Okay. Once I find my slope, then I will plug this into y minus y1 equals m times x minus x1. And you can just plug in whatever point you want. So I will use this as my x1 and y1. You could certainly use the other point if you wish. So I will have y minus y1, which is 825, equals my slope, which is negative 175, times x minus x1, which we knew was 1996. Okay, distribute this negative 175 through. So y minus 825, I know these are really icky numbers, but we can do this, equals negative 175x. And then negative 175 times negative 1996 makes positive 349,300. And then I need to add that 825 to it. And I should get this. Okay, so there is the equation of that line. Now, if we were to do this by hand, would we all come up with the exact same equation? No, because we might draw our line in slightly different spots. We might pick different points on the line and estimate them slightly different. So I don't expect our answers all to be exactly the same, but they should be relatively close. Okay, then it says use the equation to predict the number of mumps cases in 2003. So again, this is the equation that we had. You won't need to rewrite yours because you are on the same sheet of paper, but I need to. So that's where we were at. Then it says use the equation to predict the number of mumps cases in the year 2003. Think about this. Remember that way back when we graphed this, either here or here, it was our years that were along our x-axis. So when I give you a year, the years are along the x-axis. So all that means is that I'm going to plug in 2003 for x. So I will have negative 175 times 2003 plus 350,125. And when I plug that in and simplify that, I get negative 400. Now, it doesn't make sense that you can have a negative number of mumps cases, does it? Okay? So the important thing about scatterplots to know is this. Scatterplots are really useful to make predictions within the constraints of our data. So here, we did not have data that went past 1999, so we really can't make predictions much past 1999. Okay? The line of best fit is really only relevant and useful within the constraints of our data, in this case from the years 1995 to 1999. Much below or above that really doesn't make any sense. And so this is how you would do it mathematically. You would plug 2003 in for x. However, it is not a good prediction because it is out of the realms of our data. Okay? All right, and we're going to do one more like that. This time we're looking at the U.S. population. Our population is in millions, notice. You have to really pay attention to that. And so I'm going to do this. U.S. population. I'm going to put in millions in parentheses by year. All right. So again, our year is going to go on the bottom down here. And our population in millions will go on the side. Okay. And then we are going to figure out how to scale our axes. And so here our years go from 1650 all the way to 1998, not scaled evenly really at all. So if I think about going basically from 1600 to the year 2000, I might want to think about going up every 100 years. Okay, so I'm going to just put this as 1500. This is 1600, 1700, 1800, 1900, the year 2000, and the year 2100. Seems like a long ways away, doesn't it? All right. If we look at our population goes from 500 all the way up to 5,000. So if I have to go up to 5,000, I probably want to scale my x or my y-axis by 1,000. So I'm going to just start at 0 and go 1,000, 2,000. Okay, notice I did not just take my data points like for the years and go along the x-axis and plot the point 1650, 1850, 1930, 1975, 1998. I didn't do that. You have to have your axes scaled evenly, okay? So you can't have a jump of 200 years and then a jump of a different amount of years. That doesn't work, okay? So, here we go. Over here now, I need to plot these points. So I am going to plot the point, first of all, 1650 and 500. That comes from this ordered pair right here. 1650, 500. So 1650, 500 would be right here. And then 1850 and 1000 would be here. 1930 and 2000 would be right about there. 1975 and 4000 would be right about here. And 1998 and 5000 would be right about there. Okay? So that's what my dots should look like, something like that. Okay, then I think I forgot to do this on the last problem, but describe the relationship. What I want you to do is tell me this. What's happening on the x-axis? So, as whatever's on the x-axis, okay, so that you can kind of follow this formula. In this case, it would be years. As years, and then you're going to tell me, do they increase or decrease? So as I'm moving to the right, are my years increasing or decreasing? And if I'm going from 1500, 1600, 1700, 1800, my years are increasing. So as years increase, and then right here, you're going to tell me whatever's on the y-axis. Okay? And this, yeah, whatever's on the y-axis. As years increase, so in this case is my population. What's on the y-axis is my population. And then tell me, does your population increase or decrease as you move to the right? Well, as I'm moving to the right, these y values are getting higher and higher and higher. So as years increase, population also increases. Okay, if I go back to this other one back here, and I ask you to describe the relationship. In this case, my years are increasing as I move to the right. So as I move to the right, years increase. As years increase, mumps cases, what's happening to your mumps cases? Are they getting bigger or smaller as you move? And here, as you're moving to the right, the number of mumps cases is going down. So your mumps cases decrease. And that's all I need you to say. Okay? All right. Back to this. Here was our dot. I drew in a line of best fit. And again, you might draw yours in slightly different, but I've got some dots below the line, some dots above the line, and I kind of tried to average that out a little bit. Okay? Then I am going to pick two. And by the way, that line of best fit does not need to go through any one of your dots that you graphed. Okay? It does not need to go through any one of them. In this case, mine did, but yours, it does not have to. Okay? So I am going to pick 2 points that are on this line. I'm probably going to pick this one because that looks like a nice even one that goes through an increment, and that happens to be the point 1800 and 1000. Okay, and then I probably will pick this dot just because I know the coordinate for it, and it happens to be on the line, and that is the point 1975 and 4000. Okay. All right, so we are going to call this x1, y1, x2, y2. Okay, and now we are going to first of all find our slope. So our slope, we know, is our y2 minus y1 over x2 minus x1. So we know that that comes out to be negative 3,000 over negative 175. And then it's okay if you just give it to me as a decimal, that's fine. You should get 17.14 right there. Okay? Then you will use that in the formula y minus y1 equals m times x minus x1. And so we will go y minus, again, I'm using this x1 and y1, okay? So y minus 4,000 equals my slope, which was 17.4, times x minus x1, which was 1975. Y minus 4,000, I'm going to distribute this, 17.4x. 17.4 times negative 1975 is negative 3,300 or 33,851.5. And then I will add 4,000 to it. These are not pretty numbers at all, I know that. And I'll get 17.4x, 33,851.5 plus 4,000 is negative 29,000. 851.5 about. Okay, so there's our equation. Then in the next slide, and I'm just going to copy this if I can here. Oops, that's not what I wanted to do. It says predict the population in the year 2011. Okay, so first of all, I need to get my equation here. All right. All right, there's 11, or there's my equation. Okay, the year 2011, again, we plotted the years on the x-axis, and so because we plotted the years on the x-axis, we need to plug the year 2011 into x. Okay, so that's what I will do in this first case. I will go y equals 17.14 times 2011 minus 21,851.5 about. And when I do that, when I simplify all that, I should get 4,617.04. And really, this is millions of people. Okay. Again, this is not a super accurate prediction because I have used the year 2011 and my data only goes up to the year 1998. So this is not a great prediction. Next, in approximately what year is the population 3,500 million people? Okay, so population is what I put along the y-axis. So in this case, I would put 3,500 million in for y. And I would have 3,500 million equals 17.14x minus 29,851.5. Okay, so all I did was put that 3,500 in for y into my equation. Then I will go ahead and solve it by adding this big old nasty number here. And when I do that, I get 33,351.5 equals 17.14x. Divide by 17.14. The next comes out to be about the year 1945. Okay, it's not perfect, but it's about the year 1945.